The last video showed how we gained our equation of our regression line, and that was the line is like your best fit line, and it's been calculated to minimise all the vertical heights of your crosses, your actual points from the line, and we got this equation. Now we can use this equation to make predictions, just like in GCSE. You might be asked if a tree had circumference 0.6, and tree circumferences are x here, it would say use your line of best fit to find an estimate for the height of the tree. You would go up to your equation and across. Well, we do the same thing here, but you have to be really careful. You can only predict what y will be from x using this line here. You mustn't use this line to predict what x will be, and there are reasons for it. But you can only use the equation of the regression line y on x to predict y. Now this is the formula we had earlier, and it's y on x. Whatever comes before the word on, you can predict that one based on this one, but not the other way around. So for example, if somebody told me that they came across a tree where the tree circumference was 0.6 metres, I could use this equation here, just substitute 0.6 in for that x, and I could get an appropriate estimate for the height of the tree. But if somebody had found a tree whose height was 7 metres, I wouldn't be able to use this equation to predict x. If you want to predict x from y, you need to use a different regression line. The first regression line we looked at was the regression line of y on x. If you want to predict x, then you need to work out a different regression line. You need to work out the x on y regression line instead. The x on y regression line, instead of, say we have some points, instead of trying to minimise the vertical distances, the y distances, the x on y line tries to minimise these horizontal differences here, well actually the sum of their squares, like we saw before. And the formula for this one is very similar. See if I can get both of these on screen at the same time. Well, this was the equation of the regression line y on x. If you are doing the regression line x on y, it looks fairly similar. The equation, instead of being that, so what I'm going to do down here is the x on y line. The x's and the y's swap over. It becomes x equals a plus by, and then each of these changes here. The a, this time, is x bar minus by bar. So just the x's and y's are swapped over on both lines so far. And the b you will be using will be s xy. That doesn't change. But down here, instead of being s x x, it's s y y. So that is what you'd use if you were predicting an x value. That's right, that's an x on y line. You use a different equation based on a different a and a different b. It's exactly the same as this one, just all the a's and b's are swapped over. And then you can use the line you get from here, which would have a slightly different equation. You can use that one to predict an x value from a y value. There's one thing you must never do with either line. If, for example, you were doing a science experiment where you had a spring and you were measuring the length of the spring as you were adding weight or mass to the bottom of the spring, you may say that the weight you're adding is x and the length of the spring was y. The weight is something that you are in complete control of. The spring length is the thing that's subject to experimental variability, if you want to look at it like that. In this scenario here, you would use the regression line y on x to predict what length the spring would extend to if you changed the weight on the bottom. But you should not use here x on y to predict what the weight for a different length. That should not be done, and the reason is you should never use a regression line to predict something that actually you've been controlling all along. You should only ever use a regression line to predict something with variability and variation in it, never something you have been predicting yourself. So the key points for regression, it all comes down to a set of formulae. You use the regression line y on x in virtually every scenario, and then you can predict y values based on x values. You have a set of formulae, you work out b first, then a, and then y. If you are asked to predict an x variable from a y variable, then you use the x on y line, where all those x's and y's are swapped over, and you have your b formula, which now has a yy here, an a formula, and your x formula.